When I was trying to understand this question, I was a little bit confused as in like where is the cylinder that the question is talking about. So I took a bit of time sketching it out for you guys. So we have a hemisphere and within it, we are seeing a cylinder, which is going to be this portion. And the shaded region is the curved surface area of the cylinder with a radius of x over 2. And to find the surface area A, it is going to be 2 pi r h. 2 pi times the radius, which is x over 2h of the cylinder, which is something that we got to find. So area is going to be 2 pi radius, which is x over 2 multiplied by the height of the cylinder. And I'm going to make use of this right-angled triangle over here. This right-angled triangle, where this is 90 degrees. And I know this is the radius of the hemisphere, which is given to me as n. And I know this is x. So by making use of the Pythagoras theorem, this is going to be square root of n squared minus x squared. So the height is going to be 2 times of square root of n squared minus x squared. So 2 and 2 can be cancelled. What we are going to be left with now is going to be a 2 pi x and square root of n squared minus x squared. And this is what the question wants us to show. And now in the second part of the question, what we are supposed to do is to make use of differentiation to find the value of x such that the surface area is going to be the maximum. So the surface area is A is equal to 2 pi x square root of n squared minus x squared. If I were to make use of differentiation, we need an expression for dA dx. And to differentiate it from here, it is going to be sort of tedious, although it is possible for us to be getting the answer. So what I'm going to do is to do a bit of manipulation, a bit of improvisation, which I think it is actually going to get us a set of solution that is going to be easier to differentiate and manipulate. And that is and to do that, what I'm going to do is to square both sides. So if I were to square both sides, let's see. So we have a square. This is going to be equal to 4 pi square x square. And here will be n squared minus x square. So I'm going to re-express this by multiplying x square into the bracket. 4 pi square is a constant. N square here is a constant. Then x square. Then minus x to the power of 4. And this is very easy to differentiate, especially what we have on the right hand side. On the left hand side, if I were to differentiate it with respect to x using implicit differentiation, we have a 2a dA dx. And on the right hand side, 4 pi square, differentiating it with respect to x, we will have a 2n square x minus 4x to the power of 3. And the next thing that we can do is, of course, we can do a bit of simplification. For example, these 2 and 4, they can be cancelled. So a dA dx is going to be equal to, I'm going to factorize out 2x or so. So dividing, I have 2, then multiply by 2x, I will have a 4 pi square x. And this will be going to be n square minus 2x square. So the next thing that we are going to do, since we are making use of differentiation to find maximum, we are going to let dA dx be equal to 0, which means that it is going to be when 4 pi square x n square minus 2x square, this is going to be equal to 0, which means that x must be equal to 0, or this n square minus 2x square must be equal to 0. Which means the x square is going to be n square over 2. So x is supposed to be plus or minus, but we know that x is going to be the diameter of the cylinder, so it must be a positive value. So we're going to go for positive n over square root of 2. And let me quote the reason here. I'm looking at x as a distance that must be bigger than 0. So we are suspecting that when x is equal to n over square root of 2, it is going to get us the maximum possible a. And we are going to try to justify this, especially when the question did mention to us that we are supposed to justify that this particular value of x is going to give us the maximum. So to justify this, I'm going to make use of the second derivative test. So I'm going to try to differentiate this again. And I'm going to differentiate it using this version here. So let me quote it again. We have a dA dx. I'm quoting this. This is equal to, this time I'm going to multiply x back into the bracket here. So we have a 4 pi square n square x minus 2x to the power of 3. And if I were to differentiate this again, I will have a d square a dx square plus, since we are doing a product rule, so we will have a differentiating a with respect to x dA dx, then multiply by, this term is going to remain the same. So we have this. This is equal to 4 pi square of n square minus 6x square. And we are going to try to test what is the sign of d square a dx square when x is equal to n over square root of 2. So let's do that. I'm going to let x be equal to n square root of 2. So when x is equal to n divided by square root of 2, substituting in, we have a d square a dx square, and when x is equal to n square root of 2, dA dx is equal to 0. So this is basically just going to be 0. It will be 4 pi square, then n square minus 6x square. X square is n square over 2. So here we will have n square over 2. Now we have this. So d square a dx square is going to be equal to minus 8 pi square n square over a. And n square is positive, a, which is the surface area, is also going to be a positive number. So d square a dx square is a number that is less than 0. This tells us that a, when x is equal to n over square root of 2, is a maximum. And we want to do one last thing according to the question. We want to find the ratio of the diameter of the cylinder to the height of the cylinder when a is a maximum. So the diameter of the cylinder is n over square root of 2. Let's try to find the height of the cylinder. Okay, let's try to find the height of the cylinder in terms of n. And from what we have discussed just now in the previous part, this here is n and here is x. So this portion here, by using the Pythagoras theorem, is going to be square root of n square minus x square. So the height is going to be 2 times of this. Okay, 2 times of square root of n square minus x square. So let me quote the height of the cylinder here. The height of the cylinder, this height is going to be 2 times of square root of n square minus x square, which is 2 times square root of n square minus x square, and x square is n square over 2. So this is going to be minus n square over 2, which will give us a 2n over square root of 2. So now we can then quote the required ratio. Let me write it down here. So the ratio that is required from us is going to be the ratio of the diameter, which is going to be n over square root of 2, is to the height of the cylinder, which is going to be 2n over square root of 2. So we can sort of like cancel away this n over square root of 2, and that will leave me with a ratio of 1:2.